Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will use integration by trigonometric substitution to calculate that integral in front of us, which is integral of square root of 4x squared minus 25 divided by x dx. Before I start solving this problem, I will remind you of the formula used in the integration by trigonometric substitution. If I have square root of a squared minus x squared, I would take my x is equal a sine of theta, and then I will take cosine of theta equal cosine square of theta is equal 1 minus sine square of theta. If I have in my integral square root of a squared plus x squared, I will take my x is equal a tan of theta, and I will take sec square of theta equal 1 plus tan square of theta. This is 2, yeah? And if I have square root of x squared minus a squared, I will take my x is equal a sec of theta, and I will use the formula tan square of theta. Yeah, I will use tan square of theta is equal to sec square of theta minus 1. And I will draw my trigonometric triangle according to the x that I have chosen. You will see at the end of this video when I solve that integral. So now, because 4 is a perfect square and 25 are perfect square, I can make it look like x2 minus a squared. So let's start by doing that. That integral, I can write it as integral of, I can factor out 4, it becomes x squared minus 25 divided by 4, and all that divided by x, and there is a square root here, dx. So now my a is 5 over 2, because a squared is 25 over 4. So I can say let x equal, my a is equal 5 over 2, because my a squared is equal 25 over 4, so the a is square root of that. So it becomes a sec theta, we said. Let's highlight it. When I have x squared minus a squared, I take my x is equal a sec of theta. So my a in that case is equal 5 over 2 sec of theta, and my dx will become 5 over 2 sec of theta tan of theta d theta, because the derivative of sec theta is sec theta tan of theta. Now, square root of 4x squared minus 25 over 4 divided by x, let's write the integral here, is equal 4 integral of square root of 4, and instead of x squared, I can write this is my x, so my x squared become 25 over 4 sec square of theta minus 25 over 4 divided by x, which is my x we said equal 5 over 2 sec theta. Let's fix the integral, the square root here, because the denominator was not under the square root. And I still have to write the d theta. Let's put this on a new line. And my d theta, we said, is equal 5 over 2 sec theta tan theta. So this is multiplied by 5 over 2 sec theta, tan theta, d theta. So if I look at this, 5 over 2 and 5 over 2, I can simplify it, and sec theta and sec theta, I can simplify it, and I can take the 4 outside my integral. Actually, I can factor out 25 over 4. So my integral become integral of 4 times, I'm factoring out 25 over 4 multiplied by sec square of theta minus 1, all that under the square root, multiplied by tan theta d theta. This 4 and that 4, I can simplify it, and the 25 outside the square root become 5, so it become 5 integral, and sec square of theta minus 1 is tan square of theta. We said we're gonna use it here. We're gonna use tan square of theta is equal sec square of theta minus 1. Anyway, it's a trigonometric identity formula that we're gonna use. So square root of tan square of theta is tan of theta times tan of theta d theta. But tan of theta times tan of theta is times square of theta. So it becomes 5 integral of tan square of theta d theta. And I know I can replace tan square of theta by sec square of theta minus 1. This is an identity formula too. So it is equal 5 integral of sec square of theta minus 1 d theta. And because of the minus here, I can have it into 2 integral. So I would have 5 integral of sec square of theta d theta minus 5 integral of d theta. And we know there is a formula that said the integral of sec square of theta is equal tan of theta. So I would have 5 tan of theta. I can factor out 5 here, and the d theta is minus theta plus c. Now I have to draw my famous triangle, and I will remind you that we took x is equal a sec of theta, so we used a sec of theta. Let's write it down here. We took x is equal, my a was 5 over 2. Where did I take it here? I did not write it, but it's 5 over 2. Yeah, here it is. My x is equal 5 over 2 sec of theta. My x is equal 5 over 2 sec of theta. I know the cosine is equal, that's my theta, adjacent divided by hypotenuse. So the sec, which is 1 over cosine, is equal hypotenuse divided by adjacent. So my sec, because it is equal 5 over 2, I would say that the adjacent is equal 5 and the hypotenuse is equal 2x, and here I would have square root of 4x squared, I think was, yeah, 4x squared minus 25. So let me erase this so I won't confuse you. Now I have tan of theta. I know the tan is equal adjacent over opposite. So I would have 5 instead of tan. It's opposite divided by adjacent, the tan. Sorry. So the opposite of my theta is square root of 4x squared minus 25, and the adjacent is 5. So here I would have square root of 4x squared minus 25 divided by 5. This is the tan of theta, and my theta here, my theta is equal, I can say cos minus 1 of 5 divided by 2x. So my theta minus cos minus 1 of 5 divided by 2x. Well, I can finish here, or I can simplify the 5 and the 5 here. It becomes square root of 4x squared minus 25 minus 5 cosine minus 1, or I can put sec instead of cosine minus 1 of 5 divided by 2x plus c. That's the solution for this problem. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.